Hi everyone, we're going to talk about graphs and graphs for the functions and some of the function properties. So first, we know that when functions are graphed, domain values are usually associated with the horizontal axis and the range value with the vertical axis. So when we graph, y equals to fx. We have this x-axis. Excuse my drawing. This pad is really hard to work with, actually. Alright, so this one is called x-axis, and this one is called y-axis, and which is our fx. Okay, so I have a function. Okay, for example, looks like this. Okay, and we want to pick a point, for example right here, and the corresponding is supposed to be straight, comes down, and obviously the y-axis is supposed to be straight as well, and I can draw it perfectly. And this is our x value, and from here that will be our y value for this point. So this point will be defined on this graph as x, y, it's x, or you can do it x and fx because y equals to fx, right? Okay, so that's the basic graph you're going to probably see, and excuse me. A function. There's some function properties. There's a definition of the even function. Which is defined as whose graph. The even function graph is symmetric with respect to the vertical axis. If the function is that, fits that, then it's an even function. So, a function whose graph is symmetric with respect to the vertical axis, to the vertical. Sorry, I spelled the vertical wrong. C-A-L. Vertical axis is called an even function. So for an odd function, basically it's the same definition. It's called a function whose graph is symmetric respect to the origin instead of the vertical axis. So only this part changes. I would use a different color. Here, even function is respect to vertical axis, and odd function, the same definition. I'm not going to write the whole thing again, and is respect to origin. So that's the only difference. It's the same kind of definition. It's just symmetric with respect to the different things. Let's see an example. So it's not really that dry. And I can graph it out. it's a bit hard using the software. Okay. Alright, so the even function basically, okay, that's where I would go. Okay. So the even function would look like this. Okay, basically, you know, fx equals to x squared. Okay, basically it will look like this. It's an even function. Okay, it's symmetrical with vertical axis. Okay, in this case, this is our fx. Okay, and this is our y. X is our domain. This is y. Okay, y-axis. That's even function. Okay. And here, odd function will basically look like this. Okay. So it will be more like that. Okay, I tried to draw a curve, but it turns out to be a line. But that's okay. Okay. Whether it's a line or a symmetrical curve, that works too. Okay, it's symmetrical with this origin, right? For example, we have this point here. Okay, this point, this point. Okay, so we draw x, it goes into y, x, we have positive y. Okay, basically we have a negative x here and negative y here, and it's the same value. Okay, and it's just basically opposite. Okay, so this one is odd. Okay, so and there are two properties respecting to even function and odd function. So when it's even function, we have fx equals to f negative x. Okay, so when you plug in the positive value and the negative value, you have the same y value, right? Okay, we can go back to the graph and see. Okay, if we have positive x value, for example 5 here, okay, and I have a negative 5 value here. Okay, so our x is 5. Okay, we basically have the same y value, right? And in this case, for example, this is another 5, and then we get another 5. It looks like a square. And when our x value is negative 5, we have negative 5 for y. So, can you guess what our property of odd function would be? Okay, it's no mystery, you probably already guessed. Okay, f negative x equals to negative f x. Alright. So the graph basically, you know, it's more direct and straightforward if you look at this graph. Okay, so you can visualize it. What does this property actually means, right? Okay, we'll do some more examples for those two properties in another video.